So here's our overview for week 9. On Monday, we're going to review division methods. On Tuesday, we'll solve 2-step worded problems. And on Wednesday, we're going to look at sorting 3D shapes with the help of the amazing Oak Academy. Then on Thursday and Friday, you will have some time on Mathletics or Genius Maths. Okay, day 1. We're going to solve problems involving division. Mild, you'll be solving short division problems. Spicy, you will solve problems involving long division, so 3-digit numbers divided by 2-digit numbers, but mostly with low 2-digit numbers in the teens, and some decimals. Hot, you'll be solving multi-step problems using long division and decimals. So let's review the short division method. The first calculation we're going to look at is 632 divided by 4. So we're going to set up our bus stop. 632 goes inside the bus stop, and 4 will go outside the bus stop. How many 4s go into 6? It's 1, remainder 2. How many 4s go into 23 is 5, remainder 3. And how many 4s go into 32 is 8. The answer is 158. I'm just going to check using the inverse. 158 times 4 should give us the answer 632. So, eight times 4 is 32. 5 times 4 is 20, add the 3 is 23. 1 times 4 is 4, add the 2 is 6, 632. So it's correct. The next calculation we're going to look at is 398 divided by 6. So again, we'll set up a bus stop. So how many 6s go into 3 is 0. How many 6s go into 39 is 6, remainder 3. How many 6s into 38 is 6, remainder 2. Again, we can check this using the inverse. So 66 lots of 6 should give us 2 less than 398. So it should give us 396 as an answer. 6 times 6 is 36. 6 times 6 is 36, add the 3 is 39. 396 add 2 gives me 398. So the answer is correct. Now we're going to review long division. So we're going to look at 924 divided by 22. We start with our coin card. So we want to write 1 lot of 22, 2 lots, 3 lots, 5 lots, and 10 lots, leaving a space. So 1 times 22 is 22, 2 times 22 is 44, and then combine the 2 to make 66. 10 times is 220, and 5 times is 110. We'll set up our bus stop and do our code. Divide, multiply, subtract, bring down. So first of all, how many 22s go into 9? It's 0. How many 22s go into 92? You can put the 9 in front of the 2 like a little remainder if you want to, like this. But I personally prefer to just leave it as 92 without the remainder. How many 22s go into 92? It's somewhere in between 3 times and 5 times, so it must be 4 times. You can just check that by combining the 1 times and the 3 times, or by doubling the 2 times. So 4 lots of 22 will be 88. So how many 22s go into 92 is 4. So 4 goes up above the bus stop. And we've then completed our division step. We need to work on the multiply now. 4 lots of 22 is 88. We've done our multiplication step, and now we will need to subtract. So this is where putting that 9 as a remainder looks very confusing. So it's actually exchange the 9 for an 8. That becomes 12. Take away 8 is 4. 8 take away 8 is 0. We'll bring down the 4. Now it's how many 22s into 44? Well, that's just 2. So 2 goes above the bus stop. 2 lots of 22 is 44. Subtract, leaving us a remainder of nothing. And to solve, we can calculate 42 times 22 and see what answer we get. Have a go at that in your books, because that links to our long multiplication from last week. Today we're going to be solving problems involving division. Create your own word problem for the calculation 34.48 divided by 8. Pause the slides here to come up with your word problem and write it in your book. Once you've finished writing your word problem, solve it. So the answer to this calculation is 4.31. There are various possible answers for a word problem, but here's one example. There is 34.48 kilograms of flour to be shared equally between 8 bakeries. How much does each bakery receive? And the solution is each bakery receives 4.31 kilograms. So today we're going to be thinking about solving worded problems using jottings, bar model, and division with decimals. So here's our first problem. Dad is making a log store. There's a diagram here to show the plank. He needs 5 equal pieces from this plank. How wide would each piece be? So I've highlighted my key words here, 5 equal pieces. And we want to know how wide each piece would be. So I'm just drawing a bar model here. I'm actually going to do a blank one. There we go. So I've got my bar model. It doesn't matter what size it is. I want to roughly divide it into 5 equal pieces. Good. So the whole bar, remember we have part, whole. So the whole bar is 20.85 meters. But we want to know how wide just one of the pieces would be. So I can use P representing a piece. So there's 5 of them, 5P. And so I simply want to do the calculation 20.85 divided by 5. So it's just short division, and it works exactly the same as division with an ordinary number without decimals. 5s into 2 goes 0 times, 5s into 20 goes 4 times. Into 8 it goes once, remainder 4, and 5s into 45 goes 9 times. So the answer would be 4.19 meters for each piece of wood. Here's my next problem. The school beehives produce 57.2 litres of honey each year. Oh, that would be amazing if we had beehives in school. 4 classes share the honey to sell on their stall at the fair. How much does each stall have? So here's my problem again. We've got the key information is 57.2 litres and it is 4 classes sharing the honey. Yeah, so the key word here is sharing. That's telling us we're going to be dividing, and we want to know how much each stall will have. So again, to visualize this as a bar model, you don't have to use a bar model every time you're 6, like I always say, but if you're struggling to understand the calculation and what you've got to do to solve the problem, a bar model is really helpful. So the whole here is 57.2 litres, and then the parts, there's 4 equal parts. Something's got a bit wrong with my bars, just going to fix those. So the 4 equal parts are each class. So class could be C, class, class, class. So I've got to split 57.2, divide it by 4, and splitting it between the 4 classes. We'll do our bus stop division again. How many 4s go into 5 is 1, remainder 1. 4s into 17 is 4, remainder 1. And how many 4s into 12 is 3. Don't forget the decimal point. So each class sells 14.3 litres of honey. A farmer sells 47.5 kilograms of carrots every week in harvest season. He sells 4 times as many carrots to Asda supermarket as to the markets. So he sells more to Asda than the markets. In fact, he sells 4 times as many carrots to Asda as to the market. So here's the market, and we can see that Asda is 4 times the size of the market. So it's taken the market size, the market bar, and it's multiplied it by 4. So this whole here represents the carrots sold to Asda. And we want to know how much he sells to the markets. So we need to identify how many parts this bar model is split into. We've got 47.5, and it's actually split into 5 equal parts, because we've got the market part, and then we have the 4 times as many, the 4 parts that make up the Asda. So we're taking 47.5 and we're dividing it by 5. 5s into 4 is 0, into 47 is 9, remainder 2, and 5s into 25 is 5. So 9.5 is the value for each bar. Just drawing the bar model up here again really quickly. So I've got, let me just make that one better. I have got 5 equal pieces. 1 is the market and 4 go to Asda. Each piece is 9.5. And all I need to work out here is what 1 piece is, because the market is 1 piece. So he sells 1 part to the market, which is 9.5. So another question you could ask here is something like, how much does he sell to Asda? Or how many more carrots does he sell to Asda compared to the market? So there's lots of different ways you could use a bar model to solve this problem. And as I said earlier, you don't need to use a bar model for every problem if you can already identify the steps. It's just a really good way when we get to more complex worded problems. As you move through your maths, you will find more and more complicated worded problems, and bar models are really, really useful to help you solve those types of problems. Gary thinks that he should calculate £6.75 divided by 12 to solve this problem. Is he correct? Explain your thinking and solve the problem. So the problem is, the local scout group are hosting a party. There are 12 scouts altogether. They all have to pay a small amount towards the party. 9 scouts have paid so far. In total, they have £6.75. How much does each scout have to pay? So far, 9 scouts have paid. There's 12 scouts altogether. So we can draw our bar model showing our 12 scouts. And each of them have to pay a small amount towards the party. We're assuming here that they have to pay an equal small amount, although it doesn't technically say that. So far 9 scouts have paid. So 1, 2, 3, 4, that's 9 up to there. So this is my 9 scouts, and that is £6.75. So 9 scouts have paid, and in total they have paid £6.75. Not £6.75 each, but together. We just want to find out what one scout has to pay. So we're just taking £6.75 and we're dividing it by 9. So I can set up my bus stop here. £6.75 divided by 9. 9 into 6 doesn't go. 9 into 67 goes 7. Remainder 4. 9 into 45 goes 5. So it's 0.75, 75p for each scout. So what Gary has done wrong is he's not read the word problem properly, and he's assumed that he's got to just share the price between 12, but actually the £6.75 is just once 9 scouts have paid. So we're not dividing by 12, we're dividing by 9. So that shows you how Gary could have used a bar model to avoid making that mistake.
Now, first of all, we're going to look at the parts of shape. So we'll start with 2D shapes. 2D shapes are called 2D because they are two-dimensional. They have 2 dimensions that can be measured. You can measure their length and their width. And you can see that on the square that's on the screen. So you can measure the length of the shape and the width of the shape. They're the 2 dimensions. So the parts of a 2-dimensional shape are called the sides. So you can see this on my trapezium. The face, that's the flat part of the shape, and 2D shapes are always flat. And the vertex, that is where 2 sides meet. And you may have heard this called a corner before. The mathematical word is vertex. So there's one vertex. And if you're talking about more than one vertex, then you refer to it as vertices. Vertices is the plural of vertex. If we look at 3D shapes, they're so called because they have 3 dimensions. You can measure their length and width, but also their depth. And we've got this displayed here on the cube on the screen, and I'll also show you with a cube here. So we can measure the length and the width of the shape, so that's the front face, but we can also measure the depth, which is how far back the shape goes. And then we've got the names of the different parts of a 3D shape. Only one is different from the 2D shape. So we have a face, which is the flat or curved surface on a 3D shape. And we have the edge, which is where 2 faces meet. And then we have the vertex, and multiple is vertices. So the different word here is edge. On a 2D flat shape, it's called a side, and on a 3D shape, it's called an edge. So I'll show you on my triangular base pyramid or tetrahedron. We have the faces, which are the flat parts. We have the edges, which is where 2 faces meet. So I can see that the 2 faces join here on the edge. And then we have the vertex, one vertex, that's the singular, and multiple vertices, that is the plural. So on a tetrahedron or a triangular base pyramid, we've got 1, 2, 3, 4 flat faces. We've got 1, 2, 3, 4, 5, 6 edges, which is where the faces meet. And we've got 1, 2, 3, 4 vertices. We're going to work more on looking at these properties in a moment. So now I want you to have a look at these two shapes on your screen and think about what is the same about them and what is different. Use the key vocabulary on the bottom of your screen to help you, and pause your video while you make some notes. So the first most striking difference is the fact that one of the shapes is three-dimensional and one is two-dimensional. The three-dimensional shape is a cube and the two-dimensional shape is a square. So then if we're thinking about the dimensions, we can label them that the cube you can show the width, length and depth, and the square you can only show the width and the length. And then you may have labelled it so you know that they both have vertices, they both have faces, although the 2D shape has one face, but then the 3D shape has the edges, whereas the 2D shape has the sides. And you may have then talked about the number of things, so the square has one face, whereas the cube has 1, 2, 3, 4, 5, 6 faces. And then you may have looked at the vertices. The square has 4 vertices, the cube has 1, 2, 3, 4, 5, 6, 7, 8 vertices. So now let's look at recognising some 3D shapes using the named parts that we've just learnt. So I've got some 3D shapes on the screen here. I've also got them in front of me to help. So we're going to think about looking at their properties and also naming them. So we'll start off with this one. And I've got the shape in front of me. So this shape is a cylinder. And I always find it helpful when I'm thinking about shapes is to think about what shape do they look like in real life. So a cylinder, which I rarely hold as like a 3D shape like this, in real life I often have a tin of beans, and that's the shape of a cylinder. So if you try and relate things back to real life, then it helps you visualize things, and you can even, when you pause the video to do some work on this, go and get some shapes from around your house that resemble these 3D shapes. So I'm starting off with my cylinder. It's like a tin of beans, and I'll think about, okay, first of all, how many faces does it have? Well, it's got 1, 2 flat circular faces, but it also has 1 curved face, so it's got 3 faces. Then I look at the edges, and that's got 1, 2 curved edges, but a cylinder does not have any vertices. So that's one worth noting. That's an unusual 3D shape. We'll look at one more together. So we will look at this shape here. Okay, and I've got it in front of me as well. So first of all, I'm thinking, I'm not quite sure what this shape is, but I can see on its face here that it's a 6-sided 2D shape. So that's a hexagon. And this shape is a prism, like a triangular prism. This is a prism. So this shape is called a hexagonal prism. And you may be able to notice another prism on the screen, which this knowledge will help you with that one. So this is a hexagonal prism. And then it's got 1, 2 faces at the end, 3, 4, 5, 6, 7, 8. It's got 8 flat faces. And I can count the edges. It's got 1, 2, 3, 4, 5, 6 on the end. So it's got 6 on the other end as well. That's 12. And then it's got 1, 2, 3, 4, 5, 6 around the side. So that's another 6. That's 18 edges. And it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 vertices. Now a tip for if you're counting them, in a shape like this, it's often helpful to get something like a whiteboard marker, which you can rub off, just so that you don't count the same face twice, or keep your finger on one face so you know that's where you started and then count around. So I would like you now to pause the video, and you're going to look at all of these 3D shapes on the screen and see if you can write down the number of edges, vertices and faces, as well as their name, and if you can think of any examples of the shape in real life. Pause the video now. So now we're going to look at identifying 2D faces on 3D shapes. So here's my question. What 3D shape could this triangle be the face of? So I need to start to reason about 3D shapes and think about what I already know about 3D shapes. So I know that a triangular base pyramid is made up of 4 triangular faces, so it could be the face of a tetrahedron. But I also know some other 3D shapes that have triangular faces. I know that a square base pyramid has got 4 triangular faces, so it could be a square base pyramid. I also know that the triangular prism, which looks like a tent, has got 2 triangular faces. So there's 3 possibilities there, and you may have thought of even more possibilities. So this one, we can't come up with a definitive answer. We would need more information in order to come to a conclusion about this question. So I want you to have a think about these 4 shapes. What 3D shape could they be the face of? Pause the video and make some notes now. So we'll start with the pentagon. We looked at it before. The pentagon could have been the face of a pentagonal prism. Now the rectangle is slightly more interesting. Well, we know definitely that it could be the face of a cuboid because they have 4 rectangles. But remember also, a triangular prism can have rectangular faces. And then also, if I think about my hexagonal prism, that's made up of 2 hexagons, but also rectangular faces. So there's lots of possibilities here. Pentagonal prism as well. Then looking at the square, well, the first one that comes to mind is a cube, which is made up of all square faces, so cube definitely. Also a cuboid, 2 of the faces on a cuboid are square. And then I can also think about, my triangular prism, which had a square face, could be that. That's got 3 square faces. But it could also be, I don't have an example of this, but pentagonal prism, if I squish that down, that could have square faces, and the same with the hexagonal prism. And then finally, the circle, that goes back to our initial shape, that's our 2 flat faces on our cylinder. I think you are ready for some independent learning now, so pause the video and complete your task. And once you finish, click restart.